This is part 2 of our study on inverse functions. Yesterday we worked with domain and range on inverse functions. Today we're going to focus more on finding the inverse of a function. And so I have this as a 5-step process. First, make sure your function is 1-to-1. Digging way back, that's making sure every x goes to 1y and every y goes to 1x, or simply making sure it passes the horizontal line test. Second, let y equal f of x. If we are using the function notation, plug in y. It'll be a little bit easier to manipulate the equation with y instead of f of x. Solve the equation for x, and then finally our main goal yesterday, switch x and y, and then we're going to use our function notation, f inverse of x, in our final answer. So we have 3 examples of doing this. There's a number of different ways you can see this, and we're going to see more as over these next 2 or 3 weeks as we go through. But on this first one right here, step 1 is get rid of this f of x, write y in its place. Okay, and all of these are 1-to-1 functions, by the way. Something you can check in your calculator if you want to, but I don't plan on throwing any curveballs as far as that goes. Next, what I want to do is I want to make it so that this x right here is the only thing on the right side of the equation. So that's going to be done by squaring both sides. And then subtracting 3 from both sides. Now careful, I still have a negative x over there. I want to solve it all the way down for positive x. So dividing everything by -1 will give me a negative y squared plus 3 equal to x. Now I'm still wanting a function of x for my answer. That's why we switch our x's and y's now. These two are actually equivalent. There's some domain stuff going on that we're not going to worry about just yet, but they're actually equivalent. I'm wanting the actual separate inverse function on this. And so switching my x and y will give that for me. Okay. And then finally, the inverse notation. I want you to know that this is my inverse. So I'm just throwing a f inverse in front. That will be my final answer. I'll let you give this one a go, and we'll work C together. C's got some ideas in it that we need to discuss together. So go ahead, pause the video. Several ways to do part B. I'll work it my way, see if it matches up, do it your way. Okay, so hopefully you get something similar to this or exactly this. I know this is the first time I've solved it this way today. A lot of times my students have told me today for this first step to multiply everything by 3. To cancel that 3, this becomes a 21, this becomes a 3y. We've solved it from there. We've gotten through the problem pretty quickly like that as well, and have gotten a similar solution that's equivalent to this one. So that's fine if you thought to work it that way as well. Okay, finally, this one over here, part C. I'll do black ink on this one. I'm going to write kind of smaller, and by the end you'll see why. So it is a 1-to-1 function, so I'm going to switch that f of x to a y. Next, I don't like dealing with fractions too much, so I'm going to multiply both sides by 7 plus x. Okay, so that will cancel here. I'm going to distribute this over here. Kind of get through this problem a little bit quicker. And so from the get-go, I hope that you see that this problem is going to be a little harder, not only because I'm writing smaller, so that kind of hints that it's going to be harder, but the fact that I have 2 x's in here. It's not something that I see a lot is people solve for 1x and call that good enough. I want to get everything, I want to make it so there's only 1x on one side of the equation and everything else is on the other. Okay, that doesn't involve x. So to get ready for that, what I'm going to do is I'm going to go ahead and subtract this 2x off of both sides. There's nothing to combine it with over here. So 7x plus xy, that x is looking kind of rough, equals 5. Okay? It's kind of an algebra 1 idea. Get everything with an x on one side, and if it doesn't have an x, I'm wanting to add or subtract it to the other side. So I end up with xy minus 2x equals 5 minus 7y. You're probably thinking, well, I still have 2x's in the equation. What good did that do? Check this out. I reduced it down to a single x in this equation. If you notice, all I had to do was pull out that GCF. So get everything with an x on one side and pull out that GCF of x. And so solving this for x now, I'm going to take this to the top. I just need to divide both sides by what is in parentheses. 5 minus 7y over y minus 2. Okay. So I have this solved for x. That is the beef of these problems. Okay. Once you get from there, we can switch our f and y, our x and y, and then write everything in terms of x. And so this crazy looking thing right here, you kind of see some of these same numbers matching here. They should. All right, just been kind of rearranged a little bit. That is going to be my inverse function. Okay. Okay, the last problem today, I know it's been kind of short. Hopefully you like that idea, is looking at the graph of f inverse. Okay, I'm going to teach this kind of the long way up front, and then I'll show you the shortcut at the end. Okay, I'm going to use my idea of what I did yesterday, where the whole idea of yesterday was switch your x's and y's. And that's exactly what I want to do today. Like for today, I have this point right here on my f function. It is the point 0 and negative 2. Okay, so whenever I do my inverse function, I'm just going to swap my x's and y's like I've done today and yesterday. And I get the point negative 2, 0. That means whenever I graph the inverse of this function, I should go through that point. And so now what I want to do is I want to choose some key other points that I see it going through or close to. Like I see it's going close to 2, 2. So imagine putting 2, 2 in this list. Okay, if I swap those, well, that didn't really do much. That means that they are going to share that point. Maybe I missed some more somewhere. I'm just going to choose a point up here close to the top. I see 1, 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 5, 8. If I flip-flop those numbers, it gives me the point 85. So my f inverse, however it's going to lie, some extra blue lines up here, it's going to go through the point 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, right here. Okay. Might need a few more points. Let me come down here and get some negative points. Ooh, right here looks like it's a good one. So 1, 2, 3, 1, 2, 3, 4, 5, negative 3, negative 5. Again, use my idea of flip-flopping those. So in my mind, I'm thinking negative 5, negative 3 for f inverse. 1, 2, 3, 4, 5, 1, 2, 3. Kind of getting more of the shape down, I hope. Yeah, I like that point. It's a nice one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Well, negative 7, negative 7. If I flip-flop those, they are the same. So if I just try to draw a smooth curve, as smooth as the previous one was through there. Oops, sorry about that. Don't let that bother you. This blue function right here is my f inverse. It does make a pretty cool design. And the reason why is because it has a line of symmetry. If you turn your head like 45 degrees to the right, I think you can see that line of symmetry running right up y equals x right here. And that's the rule for graphing f and f inverse. F inverse will always, this blue line will always be a reflection of this red line, wherever it is in this line, y equals x. Okay. And so this blue line would be my answer. Good luck on this homework, and as always, please let me know if you have any questions.